All right, so solving rational equations. So notice that we have a variable in our denominator. So I think a good idea when starting these is first note any restricted values. So for example, y plus 7, that's our denominator. In general, our denominators should not be equal to 0. That's where they're undefined. So if I do a minus 7 and a minus 7, I've got that y should not be negative 7. Okay. So what then do we do when we start solving this? Now, this is just a note. We'll come back to this and see if it's necessary that we even mention this. But now we're trying to get the y by itself. If we think of this as being over 1 and this here as being a binomial, since this is division, we can undo division with the inverse of multiplication. So I will multiply y plus 7 to the right side, and I will multiply y plus 7 to the left side. Again, if you want to think of this as being over 1 and over 1. But when you multiply like this, we can now slash these out. You might even think about it as since that was division, we're doing multiplication to move the y plus 7 over to the right. From here now, it's distribution. Distribute. So we've got negative 6y minus 42 is equal to 3. And now we've got a linear equation that we can solve. So we'll add 42, these slash out. We've got minus 6y is equal to, that's 45. And then now we can divide by negative 6. And so we end up with a fraction negative 45 over 6, which again, check to see if that could be reduced. But the main thing is right now is, again, the only thing that we said that y should not be is negative 7. But in this case, we're not getting that, so we're okay. 1 second, I'm just, is this reducible? Yes, because 45 is divisible by 3, 6 is divisible by 3. So this would be y is equal to negative 15 over 2. Just double checking. Yeah, again, I just got my calculator here and I'm just checking stuff. Yeah, 6. All right, and so we're good. Now, you could then plug that in just to make sure that it does work. I don't think I'm going to check my answers for like all of these. I mean, you should. I mean, if we had negative 6 is equal to 3 over y plus 7. Again, y negative 15 over 2 plus 7. And then that would be, again, that's like 7. 15 divided by 2 is 7 fifths. And then 7 minus 7 fifths. This is like negative 6 is equal to 3 over negative 0.5. And 3 divided by 0.5. This works. It does check out. All right. So again, you should check your answers, but just plug it back in. Make sure that it works. That it satisfies the equation. Here's another one where this time we've got a few different terms. We've got a 2 over 1, we've got a 4 over 3, and we've got a negative 5 over y. So for this one, we can use is the LCD. So more specifically, take each of your denominators, and if we multiply them together, this would be one way that we could get that our LCD is 3y. I'm also going to make a note that since y is in the denominator, we should not get y equal to 0 as a solution. Okay, that's just like a restricted. That's something that's restricted from the domain. So now, what do we do with the LCD? You can think of it this way. Here is the left side of the equation. Here is the right side of the equation. And what we could do is take both sides and multiply them by the LCD, which is 3y. And I'm going to put it over 1. I'll put this one over here, 3y over 1. And what we're doing here is known as clearing fractions. So again, multiply numerator with numerator, denominator with denominator. So we've got 6y over 1. Again, we're going to multiply the 3y times the 4 and the 1 times the 3. So we've got 12y over 3. But notice what's going to happen. We're going to be able to reduce these or slash them out. But I'm going to do that in a moment. We're also taking the 3y times the minus 5. And we're also taking the 1 times the y. So we're going to have a negative 15y over y, because y times 1. But here's the fun part, is that over here we have just 6y over 1, so we're going to write that as 6y. Here we're able to divide. 12 divided by 3 is 4. Over here we got y divided by y, which just slashes out, leaving us a minus 15. Okay, so now we can get our like terms together. Minus 4y, so we've got 2y. These are gone. Negative 15. And then divide our 2. So we've got y is equal to, we can leave it as negative 15 halves. Again, maybe for like checking, this would be the same thing as negative 7.5. And then if you wanted to check your work, you could plug that in to make sure that it satisfies the equation. I'll do it. Negative 7/5. And so we had a 2 is equal to 4 over 3 minus 5 over, okay, it was negative 7/5. Again, if we want to get rid of the, think of it as like add the opposite. So we're checking, does 4/5 plus 5 and 7/5 equal to 2? I know this doesn't seem very fun right now, but let's just do it. I mean, you could type that in the calculator. 4 over 3 plus 5 over 7.5. It does. It checks out. I just put it in the calculator, but all right. But the main thing is, I think clearing fractions is a good idea. Get rid of those denominators. And I made a note of the restriction. Just there are sometimes you get extraneous solutions when you're working with rational equations. But all right, I'm going to go ahead and just end these two. I think these are just kind of two basic solving rational equations to get started with.